Welcome to this video on covariance. In statistics, covariance is a measure that helps us understand how two variables are related to each other. Specifically, covariance measures whether two variables tend to increase or decrease together, or if one increases while the other decreases. Let's start with the mathematical definition of covariance. The covariance between two variables x and y is defined as the expected value of the product of their deviations from their respective means. More simply, we calculate how much each x value differs from the mean of x, how much each y value differs from the mean of y, multiply these differences together for each pair, and then take the average. Let's visualize this with a simple example. Suppose we have 5 data points for two variables x and y. We can plot these points on a coordinate plane. The mean of x is 3, and the mean of y is 4. Now, the covariance calculation involves looking at where each point falls relative to the means. Let's divide our plot into 4 quadrants based on the means. Points in the upper right and lower left quadrants contribute positively to covariance because in these regions, both x and y are either above their means or below their means. Points in the upper left and lower right quadrants contribute negatively to covariance because in these regions, one variable is above its mean while the other is below. Let's calculate the contribution of each point to the covariance. For the first point, 1, 2 the x value is 1, which is 2 less than the mean of 3. The y value is 2, which is 2 less than the mean of 4. So the product x minus x bar times y minus y bar is minus 2 times minus 2 equals 4. For the second point, 2, 3x is 1 less than the mean, and y is 1 less than the mean. The product is minus 1 times minus 1 equals 1. For the third point, 3, for this is exactly at both means, so both deviations are 0. The product is 0 times 0 is equal to 0. For the fourth point, 4, 5x is 1 more than the mean, and y is 1 more than the mean. The product is 1 times 1 equals 1. For the fifth point, 5, 6x is 2 more than the mean, and y is 2 more than the mean. The product is 2 times 2 equals 4. Now, to get the covariance, we sum up all these products and divide by the number of points. The sum is 4 plus 1 plus 0 plus 1 plus 4 is equal to 10. Dividing by 5, we get a covariance of 2. So what does this positive covariance tell us? It indicates that x and y tend to increase or decrease together. When x is above its mean, y is also likely to be above its mean. And when x is below its mean, y is also likely to be below its mean. One limitation of covariance is that its value depends on the scale of the variables. This is why we often use correlation instead, which normalizes covariance to a value between -1 and 1. The correlation coefficient is calculated by dividing the covariance by the product of the standard deviations of x and y. Let's look at some different patterns and their corresponding covariance values. When points mostly fall in the positive contribution quadrants, we get a positive covariance, indicating a positive relationship. When points mostly fall in the negative contribution quadrants, we get a negative covariance, indicating an inverse relationship. And when points are evenly distributed among all quadrants, the covariance is close to 0, suggesting no linear relationship. To summarize, covariance is an important measure in statistics that helps us understand the relationship between two variables. A positive covariance indicates that two variables tend to increase or decrease together. A negative covariance indicates that when one variable increases, the other tends to decrease. And a covariance near 0 suggests no linear relationship. Remember that covariance only measures linear relationships and is affected by the scale of the variables. For a standardized measure, correlation is often preferred. Thank you for watching.